What's up,
And we're
Max?
live.
How's it going?
I'm good. I'm
So
good. How are you
I do
doing?
these Shill Your Stack sessions now and then where I get some awesome people from the ecosystem together. I backseat drive, you share your screen. We check out your stack. Today, you've kind of recently been Foundry pilled. And I'd love to just like hear more about that. Maybe just to back up a little bit. You work at Zora. Is that where you're at right now?
Yeah,
Awesome.
yeah. I do like kind of dev row there, which means I just make a bunch of random stuff and experiment. So yeah, it's been dope so far.
And you got into the space like in the last year doing like NFT stuff, right? I think I remember seeing the Danny Diamond stuff, maybe.
Yeah, yeah. So I started coding February 1st of this year. That was the first line of HTML I ever typed. And
That's
then
so
yeah, the
cool.
first real project I did was a fork of the OE40
Yes.
gallery marketplace thing because I needed to figure out how to make a marketplace and like all these other templates I was using like weren't doing it. And then I was trying to build a custom Zora marketplace. So I ended up using the OE40 gallery as the scaffold for that.
That's
And yeah,
awesome.
so that's where it all started was yeah, that site I did with Danny, lost found world. And then everything has just been insanity since that happened. But yeah.
Congrats to you on your journey, man. You've definitely like killed it. Like that's so cool writing your first line of code in February. That's so neat.
Yeah,
There,
yeah.
there was a really weird thing with the OE40s where there was like a switch and you could click the switch to see either all of them or yours. And it was the
Yes.
weirdest UX UI. So to see that get forked and used in multiple places, I almost feel a little bit bad that we like made that weird UX,
Yo,
but it
that
worked. Whatever. It's
not
like,
even that pattern ended up going into all of these other sites and shit I was building from there.
wow.
So no, I loved it.
Awesome. Awesome. Okay. So yeah, I don't know. Let's get started. Let's jump into it. Do you want to share your screen and we can just like, I don't know, like what, okay, so probably like there's a lot of developers out there that are probably using Hard Hat that are thinking about getting into Foundry. There's a barrier to entry for sure.
Hmm.
You hear that Foundry is awesome and fast and good for like writing your tests in Solidity. There's
Hmm.
Anvil and all these other things that make it a comparable product to Hard Hat.
Hmm.
But like that, overcoming that barrier to entry, what was kind of like your aha moment or your entry point, or even just like, you know, what is it here that we want to show
Yeah,
off in
yeah.
terms of like why Foundry is dope,
Got you.
and
So
just like your
I'll
stack.
share my screen soon. Yes, yes, I got you.
Dope,
So
dope.
let me do quick background and then I'll share my screen.
Yeah,
So the background
perfect.
is I've been doing Solidity development, like experimental kind of like myself, but I've been doing it in the least formal way ever. I've just been doing the like remix Ethereum, do stuff that the logic should work, and then test it on Gurley, and then like, is it working? No, redeploy Gurley, no, or like Rinkby. It was Rinkby for the whole time, and then recently Gurley, and that is like cool for experimental stuff. But eventually I've gotten to the point where like I want to do better stuff, and I've gotten where like that development cycle of like redeploy, test, redeploy, you don't actually technically, you can't confirm what you're doing is actually working, even though it might like look like it is on Remix or something. So I just got like to the point where I was like, I need to do real Solidity development in like a code editor, not just like on the Remix thing, actually write tests. That I'd say that is like, if there's any theme of today, it's start writing tests right now, because or maybe not right now. Maybe you're still in the remix phase where that's totally cool to be doing. But if you're starting to want to get into stuff where it's like a lot of people could use this, you want to make sure you know it's using, like it's actually doing it right. Tests are just like mandatory. And then so pretty much I got to that phase, and then I was like, okay, I need to pick something to start writing tests in. I've used Hard Hat before when I was there was like a time I almost started writing tests when I was just getting into Solidity. It was around the time of that OE40 fork. And then I was like, nah, I'm gonna leave the Solidity up to everyone else and just like steal people's shit. So I started using Hard Hat. I've used like Hard Hat for deploy a lot before because it's just like really simple, just like scripts and stuff. But then when it was time recently, when I was like, okay, so example, I've been working on this curation protocol recently, and this is like probably the most like sort of complicated, expansive like Solidity I've written, and there's just like way too many things going on that I can't just like be assuming that they're working. So I reached the point where like it's time to write tests. I need to pick something. Everyone seems to be using Foundry. I've been told it's faster, it's more modular, you know, like blah, 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 blah. Okay, screw it. I'm gonna try and learn it. It's also what Zora uses. So like for me to do to be compatible with any of the other like crazy protocol stuff the protocol team's working on, I need to use Foundry, or else it's just like not, it's a non-starter. So I needed to learn Foundry, and I was like, okay, I had a 6-hour flight back from Bogota to LA, and I was like, I guess I'm gonna learn Foundry. So yeah, I guess I'll jump into it. So that has everything led up to that point, and
Awesome.
now I'm talking.
So it's
Now I'm
you on
talking
a
with you
flight.
about
Do
it.
you have internet on the flight, or is this a
No,
non-internet
no,
flight?
no internet, no internet.
Okay.
So I had to download everything before,
Right.
and then just like pray that I downloaded everything right. And then very immediately I thought I downloaded something wrong, and I was like, no, but I saved it, and then I ended up learning Foundry on that flight, and now I've been able to use it since. So this is like an obvious thing, but this is like where to start when you're learning Foundry. You go to the Foundry book site, and this is like all of the docs for how Foundry works and everything. And I literally just did the getting started thing. So if you've never installed Foundry on your computer before, you have to run this like curl thing, which like gets it on your computer. And then each time you run, you're getting a new repo spun up, and I'll show you that in a second. You just like hit Foundry up. That installs the latest version of like Cast, Anvil, and one other thing. And then you can just literally start from there. So then once you have that, you go next. You can use this example project they provide, which is like Hello Foundry. It sets you up with like some test environments, SRC, whatever. You have to learn. And actually, maybe I'll slow down because this is actually like an important part of it. So it's like set up your first Foundry project. You use this stuff. And I would say just recommend following like, so you get to the Foundry homepage, you install it, you go here and try running your own local environment with the tests they provide, and then just like go from there. So pretty much I use this Hello Foundry repo they provide as like an example to start like making sure I was doing stuff correctly. And then I skipped this because I didn't have an existing project. And then I figured out how to learn. So I installed a few dependencies before that flight. That was like, I needed to get it so that I could do it with no internet. So you install dependencies like this, and I can show what that looks like. You just pretty much go to repo, you go to GitHub repos directly, and you just install the name of the repo. It's kind of cool. It will show up in your lib folder, and then you do this remapping crazy weirdness, which I'll also show. And it's actually like really straightforward, but it just looks like scary. And then once you're there, you can now do stuff. And then it shows you the project layout. So yeah, this was like a really good, just literally up until this point, that's all you need to know to get started with Foundry. Download that stuff and download any dependencies you need, and then you're good to go with working. So let's actually, so there is a repo I'm currently working on in this. So public assembly, I guess backtrack is this kind of like new, bigger, like larger project effort, almost like movement type thing that I've been working on the past like 2 months now, which is sort of like, we're starting to spin out some community engineering collective vibes from Zora, which is really cool. And so here's the public assembly repo. If you haven't seen it, this is where all of the stuff we just did with the curation protocol and NeoSound, and I'm not even going to get into all that, so we can teach people how to use Foundry, but there's a lot of stuff to dig into here if you're interested, so I would definitely recommend. Right now, I'm working on updating an access control module that is getting I'm kind of redoing the curation protocol so that people can set in like arbitrary access control, and I need to do a few updates because the logic in there isn't fantastic. So I'm going to fork this actually right now. We're going to go, and you guys can see that I actually
we're
still
starting
like
from GitHub and we're making it happen. You can't do this on a flight.
No. So yeah, hopefully you have internet for this one. You will see that I still like relatively have no idea what I'm doing. But it's fine. And my desktop looks insane. And there's actually this is like there's some stuff I should not be showing right now, but here we are. So we're just gonna go get. Well, yeah, everyone don't look. Foundry testing. Boom. So we're cloning into this repo. Boom. And then you'll see that it's this whole thing. And now we're just gonna actually open up the editor and get away so you guys don't see my desktop. So, okay, here we are. We're at the outer level of this repo. We actually need to CD. Actually, let me even look. We have the instructions for how to do stuff. So you git clone, and you CD into the mod. Okay, yeah. So you have to CD into the desired module folder, which for this one will be working in tokenized access control. And then you install Foundry, which is that curl command at the beginning.
So each one of these two each one of these two directories within the repo are different Foundry projects, and you need to get into the specific one. Okay.
Exactly. Yeah. So you'll get in, and then if you've never installed this, you have to install this just like one time. And I've already done that, so I can skip that step. And then I'll hit Foundry.
It's probably like Rust and stuff. Like it needs to bring Rust down and get all those dependencies working. Yeah.
Exactly. And that stuff is all so beyond me. But yeah, that's like how it's working. So you CD into the module you actually want. I'm just checking that it's there. Yep. And then you're gonna hit Foundry up. And you'll see that this installs downloading latest Forge, Cast, and Anvil. These are like the 3 commands you work with in here. It installs super quick, which is really cool. And then you need to hit, there's like one other thing, and I'm honestly not even exactly sure. You have to hit Forge install, I believe, to make sure that your libs get downloaded, like these like dependencies you have in here. I'm actually not even sure. It's just something I've been doing. Again, I'm still kind of like figuring out how this works. I'm gonna hit Forge install because I think I need to do that. Looks like nothing even happened, or it happened so fast because they're already in there. So that's cool. And then one way you can test, so to skip all the way to what we're actually working on, is this is a test that I've written, and it's not liking stuff, but it's okay. And you can actually, to generally how I've been testing to make sure like my environment is set up correctly, is like this test works, like this is something I've been working on, and if I run it, everything should pass and it should like be able to get through that. So I'm just gonna run Forge test right away. I'll explain what this does in a second, this VV, and if it works, then I know that my environment is set up correctly.
And one thing we're noticing here is that the test is in Solidity. Uh-oh.
Yes. Okay, so it already doesn't like this. Okay, so I am going to take out these. These are, shout out Sweetman. He's been helping me work on this stuff. He's been adding some extra modules in here, and I probably didn't download his dependencies correctly. So hopefully that can just skip us past that.
Please work. Second try. Oh.
Nope. Still not work. Okay, it's because it's still grabbing this somewhere. Where is it even grabbing this from? Compiler. Oh, it might be in the actual src. Oops. No. Boom. src. Ah, here we go. And his test actually works, so I don't know why this isn't working. But anyway, we're doing this live, so bear with me. Oh, it looks like we got something. Okay.
It's doing something.
Nice. So you can see here. So this is just like we were running a test that's already been written. I already knew it worked. This is just to prove that like all the dependencies and like remapping stuff is working correctly. And it is. So all those tests is passed. So I'll go into how you're setting up your Foundry repo, I think first, and then we can get into actually what these tests are, why they're in Solidity, or what that even means. Because that's like a big difference, right, from hard hat, which is like the hard hat or the truffle. You're like doing like, and I can't speak it perfectly, right? Yeah, like you're doing stuff in JavaScript that's letting you interact with Solidity and like testing that certain things are happening. This is cool because all of it's Solidity. But yeah, so yeah, let's actually go take a few steps back, which is here's your Foundry environment. Broadcast is where when you actually run deploys, like I'm not gonna say any of this correctly because I don't even know exactly what's happening. But when you run deploys, you get like receipts or kind of like history of the transactions you've been running in here. So that these actually get published to GitHub, and then you can see like your like deploy history and like see if you had to do like you had to like find the address of something that you deployed. Like right here, it's like that's where you can go find it. So this folder only even appears after you deploy a contract, which isn't even necessary to, you don't need to do your deploy through Foundry. You can do just your testing here and then deploy however you want to. I also have been deploying through Foundry just because obviously it makes sense to have your whole kind of like end-to-end Solidity development in one place. But yeah, that's just like another piece of it. in
So that
here,
broadcast folder gets generated when you do deployments, and it's looking at what chain you're deploying to, and it's getting those artifacts, and it's kind of saving them here for you to come back to as
yes,
a
and
record of where you deployed and what the address was.
exactly, and we'll actually get to what the deploy scripts even look like, because this is what this is. But so 2 folders away. So we have the lib folder, and this is where it's like your library of dependencies. And so if you run like forge install, right, and you're trying to like install like something new, and I guess like, I actually don't actually want to ruin this whole repo, but what you
What
do
would we
is
install though? Like
so you would go
you
here,
already have. You don't have Open Zeppelin. You're using transmission stuff, I think, right? Or was this Open Zeppelin stuff? But basically, if you wanted to install Open
yes.
Zeppelin, that would be something you would forge install. Is that right?
Yeah, so you'd go, so you can, so I, at some point I did forge install Open Zeppelin, like Open Zeppelin / Open Zeppelin contracts. And actually I can show you one I specifically installed, which is the curation protocol. So you can see here, this is literally the repo name, public assembly / curation protocol. And I would go in here and I'd say forge install public assembly / curation protocol, exactly how it's written in GitHub. And then when I install that, it will show up right here. And then that would also,
Awesome.
yeah, so it's like really simple. It just works directly with GitHub, and then remappings is how you can then figure out how to integrate that stuff into your testing. And I'll explain that when I get to the
npm over
testing
on the
pieces.
JavaScript world, the similarities
Yeah,
with the JavaScript world, you would npm install different contracts, Open Zeppelin, but in this
yeah,
case you're
yeah,
using forge install. So along with Foundry, you needed a package manager, and that's Forge. And Forge is basically a package manager that's home built, that's talking straight to GitHub and finding these things in GitHub. Am I explaining that correctly?
So I think it's more than a package
Okay.
manager. I think it includes a package manager, but as you'll see, a lot of the stuff were like when I did that Forge, I ran Forge test, right? So it's like it's doing
Right.
more stuff than
Yep.
just. It's kind of like
Yep.
your commands for doing a piece of the
Okay. So
functionality
Forge
Foundry provides.
install is the package manager, and there's a lot of
Yes,
other things
yes.
that. Okay, got it. Cool.
Yeah, yeah. Yeah, and then Forge install gets stuff into your lib, and then your remappings gets you sort of setting up your dependencies in your actual Solidity files, like as you want them to be. So we're almost to that point. So I'll just show, yeah, actually I'll skip script right now because that's the deploy side of things. We don't need to be there yet. So I'll go straight into the source, which is, so this is the file I'm actually working on. In terms of
This is
like
your
a new
smart contract. Like this
yes,
will be what gets deployed. Yeah.
Yeah, so ERC 721 access control, and I've already deployed like a version of this. And I guess to go into this without getting too far, so we can stay sort of more at like the Foundry level. This is setting up like it's like an on-chain registry type thing where you can initialize an external contract in like is mapping. Why don't I actually just show this Solidity just so this makes more sense? So there's a mapping, right, that this access control sort of, well, I'm calling it like a module contains. It contains a mapping of an address to access level info. Access level info is this struct right here. And this is just 3 ERC 721 addresses pretty much. And what you can do is you can say, okay, I'm going to initialize this second smart contract, which in this case would be a curation protocol address, because this curation protocol is going to be using this kind of external on-chain registry system to handle access control. So I'm going to use this second, I'm going to initialize, or whatever you want to call, I'm going to set the address of this curation protocol. I'm going to map that to a data type, which is access level info. So now, and I guess this goes back to the curation protocol. In the curation protocol, it is now integrated with, actually, I'm going to show the whole thing because this is really cool. So
awesome.
In the new version of the curation protocol that fundamentally still works the same, the only difference is the access control mechanism. New access control. So the new version of the curation protocol, it actually imports this iAccess control registry. And we'll go back here. This is also some of the Solidity that's been written. Really basic, right? So it's just like the name of the access control module, initialize with data. That's like a call you can, a write call you can send, and get access level, which is like a read call you can send. Get access level, if you call that on one of these on-chain modules, this is a on-chain access control module. You can now write your own access control logic. And as long as it fits this interface, you can integrate it to other smart contracts, including this curation protocol. But what I'm so excited about this is now just an on-chain registry for access control that any smart contract can talk to, which is just like a cool thing, because I just had to make it because I didn't see a different place where I could do that. So I was like, fuck it.
What happens in the initialize? Can we see the initialize just for a second? How it cuts up the data? Does it cut up the data into a struct? What does it do when you initialize with data? Just to see the solidity of it.
Yeah, so this is initialized with data right here. So
it totally does. It decodes it. You split it. Instead of taking in 3 addresses, you take in bytes, and then you split the bytes into 3 addresses. I was wondering if you did that, but that's what you did. It must be more gas efficient. Cool.
Yeah, so it's that, and then what's really the reason also it's really helpful is because now when you're going to the curation contract level, and you actually have to initialize this. So this is now we're in the curation contract, the main file of it, which is called curator.sol. You now have the ability to pass in, when you're initializing a new curation contract from a curation contract factory that we have, you're now able to pass in the access control module address and then the bytes of the initializer. And because it's in bytes, that's sort of like an undefined, okay, it's just bytes. You can pass in whatever you exactly. Yep. So you can pass in whatever you want. So when Sweetman writes the ERC21, so like I've been showing you this ERC721 access control, but when Sweetman writes the ERC20 version that also has a balance check on it, that initialize function looks different, right? Because you're now having to pass in all of this other information, but it gets encoded and then decoded from bytes. And because you have the same interface working, which is that access control registry, it works. So you can now just have arbitrary access control set up however you want to, and then initialize your curator contract with that. So it just makes it way more flexible. Initially, we were just doing ERC721 gating, and we didn't even have the concept of different roles, just because it was like the easiest way to set it up. But this now lets you, it now lets the person who's setting up a curation contract and presumably wanting to decide what the access control looks like, they now have full flexibility over what that looks like. So yeah, that's what's happening in initialize with data. And then specifically in ERC721 access control, what it's doing, like that access control is happening in this get access level check. And this is like a really basic, it's really basic. I'd say like a lot of the Solidity stuff I've been doing, this whole architecture is more complicated, but the actual functionality it's doing is like extremely basic, not even necessarily gas optimized. It's just like filling a need that I just have in projects I'm working on. And I'm just doing it because it's like, you can just do these things. If you like learn a little bit of Solidity, and then especially we'll get to the test writing example too, you can like actually make sure things are working. So yeah, that's
it's funny how Solidity is such a powerful language. And there are a lot of these like simple, you see a lot of if else's in Solidity. Yeah. And it's almost like, it's almost like hardware controllers where the code is actually pretty simple, and writing through this algorithm is actually going to be very simple, but then it's going to it's going to run on all this hardware everywhere. So it has to be you have to get it right. It has to work. And same thing with a smart contract. It's going to run on a blockchain and money can disappear. Sorry, that was a tangent.
No, you're totally good. But like, it's such a good point. Cause like when you're writing Solidity, you're actually writing the structure that like apps down the line are going to be built off of. So just to give you an example, the curation contract is powering NeoSound right now. And this is like letting you pull in music NFTs that fit a certain standard using a distributed like curation token that lets like lots of different people who have that token have access to updating this playlist that's on chain. So like these things start with really basic if else statements, whatever, but then you get here and you have like, I think this is pretty cool. This is like what we did recently. That was like the first big sprint public assembly did. And a headphone just fell down my hoodie. 1 second. Is we just sprinted on like making an open source template for like making it really easy to make your own music platforms using NFTs, because that's cool, because we need that. And
You guys,
then we made
you guys talk a lot about hyperstructures, and what you're kind of like building a little access control hyperstructure here. Is that right?
yeah. So low key, there's like curation protocol is there's no fees or anything associated with it. So that itself is kind of like a curation. I it's a curation hyperstructure esque thing. I'd say like there's certain pieces.
Hyperstructure-ish. Yeah.
Yes, exactly. So it's like just in the fact that like it's totally open. You can use it for anything you want. It's not like platform locked in. There's no fees associated necessarily. There's actually zero fees in it, which you could say is the reason it's maybe not a hyperstructure because there's not necessarily like
No
an
expansive
incentive.
fees,
Like
right?
yeah, there's no expansive fee, but I don't actually think like that's necessary. There's like you could describe hyperstructures in different ways. You don't have to call everything one thing or not, but it's pretty much I'd call it a public good for sure. Where it's just like if you need a way of pinning information or like what matters to you on the internet, you can use the curation protocol. And then yeah, what's cool is you identified that correctly is this access control module thing is actually not it's not necessarily related to the curation protocol. The curation protocol is going to be using it to handle its access control, but you can now use these access control mechanisms for literally any smart contract. And so yeah, that's like becoming a cool thing. So what happens is you have this get access call that's defined in the I access control registry, and then you just set up your logic in it to like hit those things. The curation protocol needs us to be returning 1, 2, and 3 because, and okay, I'm sorry for how much I'm flipping back and forth between these things. This is probably a little insane. But so what you can see here is only admin or only owner or admin access modifier that is used to gate some of the more administrative functions of the curation protocol, like update renderer or update access control, some of these things where you don't just want, or this is a decision we made, but it's like, yeah, you might want different access roles. Like maybe there's people who can actually update the fundamental like parameters of the contract, but I want another role that's like the curator role who's like allowed to upload songs to my NeoSound playlist. And maybe there's another role in between that called manager that can actually remove songs and provide some type of like content. What's the word for it? Like content, like it's content management, but it's like something like that. Like you can have oversight. So if people are like uploading like random crazy stuff that's like not good onto your
like
thing, you can remove
or something.
Yeah, that's what it is. It's like providing like content moderation ability, but maybe you want that moderation ability to not be tied with the ability to like update the entire access control of the entire contract. So like it just gives you the ability to have roles, which is another thing we didn't have. And you can see how it's working is in this only owner or admin access modifier, you check, you call that I access control registry. Yeah, it's so basic. And I think we need to add like that's another thing I need to add. It's probably like we should turn these into like variables.
Turn those into enums with like big obvious enums words.
Exactly. Enum specifically where it's like admin level or something like that. Not where it's just like 3. Like what the fuck does 3 mean? Yeah, yeah, exactly. But that's what's happening here though. So you run get access level and it does this really basic thing. And again, this is like specifically to the ERC 721 access control module. You can set up any access control you want. This is just the one we're using. And it checks to see if the user who's calling that, or like, sorry, it checks to see if the address that you want to get the access control, like their level of, do they own the admin access token? If not, or if their balance is not equal to 0, meaning they own it, return 3. If not, go to the next one. Return 2, return 1, or return 0 if they don't own any of these things. And just that right there allows you to have this access control and this like concept of roles in this external contract, being the curation protocol, that is just super flexible and dynamic. And now you can start using that. Again, you can make this whole call in your own access control module. You could make this a crazy convoluted, super complex thing as long as it's returning 321. It doesn't even have to return 321. That's just like we're returning 321 for the curation protocol. It can return anything as long as it just returns a number, uint 256. Then it's compatible with this interface and stuff works. So purposely keeping this I access control registry like as bare as possible Again, it's literally just name what you need to initialize your contract with, and then get access level. Maybe there will be reasons to add more at some point, but definitely trying to keep it as limited as possible to start. So yeah, that's I think that's like a decent run through of like what this access control module is doing, what the curation protocol. We didn't even really go into the curation protocol. I think that's like a whole other thing. But how the curation protocol is integrating the access control, and then yeah, I guess now I can show how I'm writing tests for the access control.
I imagine
And
some sort of test is going to say, give this account one of these admin NFTs, and then make sure they can do an admin action, or even maybe
yes,
check their role and make sure their role is a 3. Kind of those kind of tests. Is that what we're up to next?
yep, that's exactly what we're doing. So let's get into test setup. And there's a lot more tests to be written for this. We've only like spec'd out some of that very basic initial testing that you kind of just described. I like get input. So yeah, I just now to go through the test, I get like these weird import issues a lot with Foundry, and I don't even know why they're happening a lot of the time. So I'm gonna just skip over the fact that these are red. I hope that's okay with you guys. The stuff is working. It'd be better if I could explain exactly why these aren't working. It's obviously it's some file import isn't working correctly. And I don't know exactly why, but I'm gonna skip past that. And
my wild outside guess is this remapping that you're doing is only valid within the Foundry files, and VS Code doesn't follow your remappings or something random like that. I have no idea though.
Yeah, it's like, and sometimes I don't get these access control errors, and sometimes I do. Like when I did this initial file, this is like we remember we git cloned into this. Though the original repo where I like started all of this, it didn't have those errors. But for some reason, when I'm doing this like git clone into it and then Foundry up and install, it is. So anyway, that may or may not matter to you when you're actually trying to replicate this. We can still talk about all this stuff and what's happening. So just like any Solidity you're writing, this test file is a Solidity file itself, and you do imports the same way. So these initial imports are you're importing. It's like a Foundry provided testing library that comes with all these cool like assertions and stuff. Do we still have Foundry book open? Yeah, if you go to Foundry book and you search assert, nope, that's not how you spell assert. You'll get to this like DS test reference thing, and these are like kind of like some of the tests you can do where you can see like, does this thing equal this other thing, or is this thing true or not? And that's kind of what is driving all of the testing logic. So you import the testing stuff, you import like this like it's like a virtual machine instance. Can't really explain exactly how that's working. This is a Open Zeppelin kind of like ERC 721 implementation that just like works out of the box really easily. And then this is me importing the access control module, the interface, and then this mock curator contract, which is like representing what a curator contract would be, to start figuring out this logic. So you initialize some variables at the beginning. So this is me, like I'm setting up, just again, all this has to work like a normal Solidity file, because it's all in Solidity. So you still have to do the same like initialization stuff. So I'm setting up the fact that there will be 3 addresses of type this Open Zeppelin implementation, and they'll be called these things. I'm setting up a VM simulation, I guess is the way to describe it. I'm setting up some addresses that I want that will kind of represent like kind of people's wallets and stuff. Default owner address and default non-owner address. And then you run this setup function, and this setup function, this is like actually like a part of Foundry, is like when you run the setup function, or this gets ran every time you run forge test. This starts it, and then that sort of it creates like a local environment through which you're then operating with these other tests that you can run after. So this setup is a key one. What you can see here is I'm starting a prank, which is like so that's another thing. And this is where I will actually point out, let's see if I can find it. This is a good place to start messing around with Foundry 2. Shout out Natter. He has a Foundry something that was like a good place.
I saw
he has like
a workshop there.
Yeah, so
cheat
that
sheet.
is probably
Oh,
really
no.
helpful too. I've never looked at this,
Yeah.
but this Foundry cheat sheet is kind of like how to kind of skip through all of these important things and just like start understanding how to do stuff right away. So he explains, he has a good like cheat codes explainer. So Foundry comes with cheat codes, including start prank, that lets you
Which
sort of
means
like
basically like
do
taking over that
funny
address.
things. Yeah, exactly. So it's like, okay, in the setup, I'm going to set up this environment where I'm going to be acting as this address when we start doing things. I'm going to initialize these 3 different ERC 721 contracts, and then I probably don't actually have to call stop prank here. This is just me not knowing what I'm doing. So yeah, that's the setup. And then now, so once you have that, you have your imports and your test file. Again, so these test files are marked with a little T in them. And then they live in your test folder in this whole repo that you're working within. And then this will pretty much when you run Forge test, anything that has a .t, that sol in it, that's in your test file will be ran by Foundry. I don't even know if that's the right way to say it, but it will get it will be run. Some Foundry is running it. I don't mean to use passive voice to avoid the fact that I don't know exactly what's happening. But something is happening where it's running those specific files that have a .t in it. And so yeah, once you get that set up, now you can start writing tests. And then this is what tests can look like. So what you said, let me see. So this is me checking to see, okay, I want to make sure something has curator level access. And if remember, curator level access in our case means, do they have a balance of not 0 for
At
the
least
curator?
Yeah.
Yeah, exactly. Of not 0. And also specifically, they don't have a balance of at least 1 for these other ones.
Oh, right. Okay.
Also,
So they don't
because
hold an admin
yeah,
or manager NFT. They hold only the curator NFT. Yeah, I said that wrong.
exactly,
Nice.
exactly. Yeah. So you'll set up, you start prank again. I'm gonna mint a ERC 721 curator address, like access level token to the default owner address. And this mint function is coming from this Open Zeppelin ERC 721 implementation. I'm going to initialize an ERC 721 access control. Not even initialize the contract yet. I'm just like creating the contract. So the module now exists. I'm gonna this is like how you kind of do like new contracts in Solidity. This isn't unique to Foundry. This is just like, if you want to make a new version of a contract, like a clone of it.
That's what it
kind
looks
of.
like when it's like a factory. When you say new
Yeah.
contract, it actually deploys that new contract as if the originating contract was a factory contract.
Exactly. So that's what we get here. So we're just like initializing, or sorry, I don't want to say initialize, we use it differently. We're creating a new ERC 721 module. We're creating a new mock curator file, and then we're going to call that initialize access control, which in this case we are calling. If we go back to this initialize access control, actually no. So we go into the mock curator, and this isn't actually exactly how it works. What it actually looks like, because we're actually doing this correctly, is you call this initialize function, and a lot of this stuff happens, right? Including initializing the access control and the access control initializer. This is like, because this is why it's called mock curator. It's not actually the curation contract we're interacting with. It's just representing that. So in this instance, mock curator lets you call initialize access control, and you pass in the access control address that you want to speak to, and then you pass in the variables that are going to get encoded and then like pass into that as the initializer. So here we are. We've created the mock curator, and now we're going to initialize access control on it. So these 3 addresses are going to get fed into initialize with data.
And these are basically 3 different NFT contracts that ownership of these NFTs means that you have a certain admin level.
Exactly. So specifically for this access control module, it's this struct is pretty much created. And these are the different access sort of roles we're deciding exist. And then, so just that right there, we've minted the ERC 721 curator access token to this address. And then we've initialized this access module. We are now, which means just to
now we
like,
can test. We've got
so
everything in place. Yeah.
Exactly. And what that means, when you initialize, again, you're going to this access mapping of this access module. and you're saying, hey, this mock curator that we just set up, we want to say that address is now in this mapping, and we're going to map it to this access level info struct right here. And all access level info structs will look exactly the same for this module. And now this mock curator is associated with this specific version of the access level info, or not like version, but it's like this. It's associated with those specific addresses that we just passed into it, which are these 3 addresses in the test file. So that's a lot of setup to get to the first test. But now we can see, is this actually working? So assert true. This is saying we want to make sure that when I call this function, or when I enter like parameters in here, or like some type of logic, I want to make sure that it returns a true at the end of it. So this is saying, hey, mock curator, let me call this access control proxy contract, which if we go into here, if I've, no, this is the wrong file. And this is where we can see if I'm actually doing stuff right. Oh yeah, so if we go into here, this is a variable called access control that when we are calling this kind of fake initialized access control function in this test file, we want to make sure, when we do that, we're gonna set the access control proxy variable in storage of this contract equal to the access control address that we passed in. So this is just
me basically making sure that line 28 worked. Like, did it set that address like it should have during the initialization? Yeah,
exactly. And now, like, and that's important, right? Because you want to make sure now when you're doing these like follow-up access control tests, are you even talking to the right access control module? That's like an important thing to confirm. So this assert is saying, hey, get access level proxy, which is just saying, oh, I think it's literally just this, get access level proxy. Nope. I'm gonna figure out where this is actually coming from. Oh, sorry. It's a public variable called access control proxy. Yeah, sorry, it's not called get. It's just access control proxy. Because it's a public variable, you can it automatically comes with like a getter function attached to it. Yeah. So you can actually just call that as a function, and you're saying, and that just like returns what the value is. So you're saying, okay, I'm calling this, is that value equal to this access control address that we passed in? Because it should be if this is working correctly. And then it is. So one thing that's really cool, and I'm gonna, for the sake of these test results not looking completely insane, I'm going to comment out some of this stuff so we can just look at what Foundry is reporting out. And this is where Foundry gets cool, or at least for me, because I think this is actually where just testing in general is really cool. And then specifically Foundry returns some really cool stuff. So you can, Foundry gives you like different reports out on your test results depending on this. Okay, so I'm running Ford's test, and you can either say like VVVV, or you can do VVVVV or VVVV, 4 Vs. And depending on how many Vs you're putting there, it's giving you like more in-depth information about like the test you're running. Yeah, so I'm gonna do all 4 Vs, which is like, give me everything you could possibly give me. Yeah, and so let's just run it and then like walk through it. I haven't even gotten to what those other tests yet are. And so pretty much what it does is it gives you this whole like down to like, I don't even know the right way to describe it, but down to like the function call, it's giving you like gas readouts, it's giving you like bytecode of certain things. Or I think you can have it return like actual like bytecode or like operators. Again, this is a little bit over my
way over my head too. But yeah, it's like you're down to the calls for sure. Like you see the different static calls and what the argument.
Yeah, so this is what's cool, right? So you run this test, and right now the only test that exists in this test file is test curator access, because I just commented out the other ones. So you're running this test, and it actually shows you step by step what's happening. So we're starting the prank. You're starting the prank with the address of that default owner address, which we initialized at the beginning. Then we're going to mint a token to that address, and you can see that's happening here. That mint results in some stuff. It results in the transfer, and you can see that being emitted as a transfer event. And then it's going to say, okay, new access control contract, we're deploying that, and this is the address. It gives you that at here. And then it says new mock curator, gives you that address too, and that's what's happening here. Then it's saying, Oh, it's assigning the ownership of the mock curator to the address that we're currently operating as, this default owner address. As you can see here, ownership transferred from 0 address to the address we sent it from. And then we're actually running that first test. So initialize access, or this isn't even the test yet. And I'll do a little more split screen so this looks, we can see it a little bit more. So we're calling that initialize access control function, and we're passing in these inputs, and you can see it's actually letting you see the inputs. Because remember, initialize with data, you're passing in a bytes encoded thing.
You can see the addresses in there though.
Exactly. So you can see the addresses in what's emitted. This is why events are important, is because we're passing in this crazy bytes thing that is like kind of meaningless, but you can actually now in this event that we're emitting, which is access control initialized right here, we are seeing
those look like
what
addresses.
actually got passed in.
There's zero padding to get them to 32 bytes, but it looks like there's addresses in there.
Yeah, that's actually a good point. These might literally be addresses too. I don't know how like bytes encoded stuff works, but oh, it is. Look, yeah, 1A94, 1A94. Yep. So yeah, so these are just, I guess it's putting all the addresses together. I've never realized that. That's cool. So yeah, so it's just going through and showing you everything that's happening at a really granular level, so you can know that your Solidity is working exactly how you want it to. And so it finally gets to the point where we've explained what this assert is doing, which is like, was that address set correctly? It finally gets to it right here, mock curator access control proxy. It calls that function, and it should be this address, which is the same address as somewhere up here. Initialize with data. We wanted it to be this thing. Let's see if we can actually find this. Right here. So remember when we created this new access control file with this line, it got spat out at this address, right?
So that's where the contract is deployed to. The contract's address is C92B. Yeah.
Yep, exactly. So this access control call, the get access proxy, for the statement to be true, it needs to be equal to that address. And we can see here in the Foundry readouts that the address that this contract was originally deployed to is the same as the return value of calling access control proxy. And then it's green because that is representing that assertion.
Could we see it go red? Like, could we go on line 46? Could we replace the access control with like the curator address or something random like that?
I think like we can literally just do like, yeah.
Oh, so you could just say address 123 and go. Yeah. Yeah.
Yeah.
Just so you don't have like a weird test in your code that ends up being strange. Yeah.
Yeah, exactly. So now we should be able to do the exact same thing, and it will be like, yep, boom, assertion failed. And it's cool too, because you can like see where these assertions fail. Okay, it ran all of them, which makes no sense because
like
test. Okay, so reason assertion failed, and it says test curator access. That's where it failed, right there. So we should be able to go up here and see where it bounced. I'm not seeing it. Oh, right here, error assertion failed.
I'd make that super red. I feel like this display is already so beautiful that like making that red would be an obvious thing to.
Right.
Maybe not.
I think I personally think that would be really helpful if they made this red, because that's you could just see boom, like, or at least when you're reading back in these results. And also, let me give some other views of like, this is us getting all of the information possible.
Oh,
we don't actually have to do it at that level.
Yeah.
So if you just run with 2 V's, it's just like, yo, your thing failed. And then
failed.
Yeah, no, so maybe a lot of the times you're running it just as BV because you just want to see if things are working. And then if stuff fails, you can be like, oh, why did it fail? Let's go get some more information. Yeah, and then you run it with 3 Vs, right? And then it's like, that's like, I don't actually know the difference between 3 Vs and 4 Vs, but yeah, there's like some difference there. You can still see when it's calling access control, it's now emitting error assertion failed. And that's because this wasn't equal to the other thing that we wanted it to be equal. So, because we set it equal to address 123 instead of like this, right? So now if I go back and I reset that to what it should be, and I run forward test VB, everything should pass, and it did. like we think so. So that is like what running one assertion looks like. So the reason I took so long, I'd say, to get to the point of doing Foundry or doing Solidity testing is because to even get to this line of code right here, you have to set all of your repo up. You have to set all of this logic up. You have to write Solidity that's even like something that you want to test. You have to do all these wirings. You have to get into your remappings, which we didn't even talk about. And then, only then, can you run forage test VV and then actually start getting these cool readouts. But this is actually like an essential, you have to get to this point.
This is how the pros do it.
Saying. Yeah. So I was so hyped when I got to this point because it meant it for the first, like I ran that first test and it worked. I was like, this is doing actual, not that doing Solidity development in Remix or whatever other thing you're doing isn't also actual Solidity development, because it is. It's you deploying contracts and now it's working. But to get to the next level of like going from like what I would call myself like super beginner, kind of on the experimental stage, to like, okay, I want to actually do this at like a more legit level and build bigger systems that are more impactful and more safe and more everything, you have to get to the testing point. But now it's really cool because now I did the 6-hour flight download, learn how to do everything, and on the other end of it, I came out being able to do, to me, what feels like real. Again, not real, because I don't want to diminish that, the more experimental phase, but just like more structured Solidity development where you have way more control over your variables, your inputs, and like you can now start building hyperstructures. Like you can't, pretty much like, it's probably not the right move to be building hyperstructures with no tests in Remix Rinkby deploys and then just YOLOing them to mainnet, because the chance that they're wrong is like, or something's messy in there is like so high, you know? So when you're doing these things that are supposed to last way longer or be interacted with more people, it's just like, it's on you. I mean, like you can do whatever you want, but I would say it's probably on the responsibility of the developer to like be way more serious with making sure that what the code is doing, what they think it's doing, is what it's actually doing. Because there's long consequences with Solidity that lives forever, to be right, you know, or because if it's not right, it's going to be wrong at some point. And then if there's a lot of, it's what's nice with the curation protocol is there's no funds directly held in it. So it feels like a little bit less serious, but imagine like you're writing one of these crazy bridge contracts, like really hope you tested it or else, you know, and like, it's not like people with all those bridge exploits haven't been testing their stuff. Obviously they have, and probably spend ridiculous amount of time testing it. And it goes to show like even that isn't like a panacea to not having exploits happen. You still have to do the Solidity correctly, and like you can't necessarily test for everything. But this is definitely a way to get closer to the point where you can be more sure that the stuff you're doing is safe, is actually what you think it's doing, is doing the intended whatever. And I think, and that's just really cool, because that was like out of my reach for a long time, and then finally taking the time to learn it, I feel like I've now unlocked like the next like big room to run in terms of my Solidity development. And then maybe I'll run into the end of it and be like, dang, now I need to learn like assembly or like Yule or these other crazy low level things. Yeah, but that's coming later though. That I can see now where I would even remotely start thinking about that stuff. Whereas before it was like, I'll actually never do that shit ever.
That's me.
Now I can at least see where I would go. Yeah.
Yeah. So, okay. So there's a few topics that I want to cover real quick. The first thing is just like this idea of testing in Remix versus testing with tests. It's actually faster to test in Remix, right? I mean, if we're going to write a quick smart contract and we're going to test the ownership pattern, we're going to create a simple require message.sender is owner, right? To test that in Remix or Scaffold ETH is super easy. You hit deploy, you come in and you try it as not the owner, and you try it as the owner, and you see if it works and you see if it doesn't work. And that works for tinkering and figuring things out. But like you said, that's probably not the way you want to be setting up a long-term project that has to exist on chain forever. You probably want more tests. And even when you go to an auditor, if you go to an auditor and everything you've done has been in Remix, They will yell at you a lot. Trust me. The auditor wants to see a good test suite. They want to see that you've at least done your homework before you come to them for, you know, their $1,000 an hour service or whatever you're paying for, right? So one thing is, I do want to lean into, you can quickly get things done in this remix scaffold ETH pattern, but when we're talking about hyperstructures that need to live forever and get attacked forever, you need to have this comprehensive test suite. And like you said, a comprehensive test suite is not a panacea. It's not going to solve everything, right? There's a lot to it. And even like when we're talking about a smart contract system, it gets even more complex with all these things interacting with each other. So it's just one of those things that, as you become a better and better Solidity developer, it's hard for me to like teach, because I'm like not even smart enough to get to this level, but I'm like trying to teach like the getting started stuff. My brain assumes that this is where you need to be next, is you need to be writing tests, you need to be in Foundry, and you need to be building much more kind of advanced tests and structures to test. Oops, I hope I didn't just cut my audio. You still hear me?
No, we could hear you. We could hear you the whole time. Yep.
Cool. Okay, the next thing, quick little question just about deploying. How do you orchestrate this system in production once you have kind of your test running and you kind of like it? Is there a you know, a forge deploy, or what does that kind of look like? Just quickly, we don't have to dive too far into it, but just kind of to hint watchers. Yeah.
Totally. Oh yeah. So this is actually nice because this took me a little bit to figure out. So I've actually put exactly what to put in here in the deploy script itself so that I don't forget. So once you get to the point where you're ready to deploy something, there's this script file you'll see. That's also part of that like Hello Foundry initial kind of like repo they set up for you. And then this file, again, it's in Solidity. It's just like really basic, lets you deploy stuff. These are notated as .s.sol. So we have ERC 721 access control.sol. We have the same thing but .t, and then the same thing with .s. And the S is representing script. And script is kind of like a relatively on the newer side of like Foundry functionality, where it lets you deploy contracts. And again, you can set up all types of logic in here too, which is cool because it's in Solidity. You can do the same thing with the JavaScript hard hat stuff, but it's just cool that it's in Solidity. So you run setup, which is just some default thing that automatically runs from importing forge script. And then there's this function called run. And then this is where the logic for your deployment actually lives. So
but this is shaped the same as your orchestration. Your test orchestration still had that setup and run file. So it's kind of the same thing that you're doing locally, but now you're pointing this thing probably at a mainnet fork or mainnet or some other RPC.
Yep, exactly. So you're going to have a .env where this is my .env.example for this, where I'm passing in these different RPC endpoints, girly mainnet right here, and then I'll have a private key that is like from my developer wallet that is not important. If I somehow screw up and like push this to GitHub, don't put a private key that has anything of value right here. And then your Etherscan key, which is maybe something not everyone's aware of, but like you can now, I think actually one of the most helpful things for me from Foundry, and I'm assuming this is similar with like hard hat and stuff, remix, that verification button like works like 20% of the time for me. So it was really frustrating when I was doing these contracts and I couldn't like always have my thing get verified. And it was sort of just like at the mercy of, is Remix handling this verification process for me correctly? So this Foundry, like this just works. This like will verify your contract if you have more, I guess,
you do a
calls
deploy,
left.
it deploys a whole suite of contracts and they all just are verified on Etherscan, and it handles
exactly
all of that
and
for you. Which
on
is
whatever chain you want. Yeah, it's such a pain. So this just cleaning that up is like so nice. So yeah, so you load in the way you actually do this is so what's happening in the Solidity is you're like setting a private key up, which it's grabbing it from your .env. And again, this is how you can do it in Foundry. You then start broadcast. And again, that's a reference to this broadcast folder, right? So you start your broadcast. Broadcast is like, I'm deploying stuff. And you're setting up who's deploying as the private key that you just pulled in from your .env. And then specifically with this, I'm saying I want to deploy new ERC 721 access control. And then you're going to stop the broadcast. So all of that gets run. and then report it out. And I think I can actually just do one of those here. And then I wrote the scripts down so I didn't keep forgetting them. I'm actually,
and saved to your
I don't
broadcast
have,
folder too.
yeah, exactly. So I don't have my, well, I guess, let me stop
It's not a big
screen
deal.
sharing.
I just wanted to give a hint. I just wanted to give a hint to folks of, once you have your test suite going, once you have this all set up, deploying is actually going to be really easy because you already have all your orchestration ready to go. You just kind of point it at a different RPC and let it go. And it looks like it kind of records what it does as it's deploying it and gives you those kind of artifacts for your front end or wherever that's going to go.
Exactly. And I'm actually going to grab, actually, no, there's too many things. So I have to go grab an RPC URL and like all that stuff. But pretty much what I would do if I was to deploy is I would copy, for me specifically, because I keep forgetting how all this works, you would type source.env, and this like loads your environment variables into your like Foundry setup. I don't have a .env, so this is giving me an error. And then I would just run this script, this command, which is running forward script. It's grabbing this Solidity file and it's running this specific contract in it. And then it's taking in my RPC URL, which I have different ones set up depending on where I want to deploy to. It's then running this broadcast command and it's running this verify command. This requires you to also have an Etherscan API key set up in your environment variables, which I do. And then this same VV thing is like showing how much result, like how many results or like information about your deploy are showing up upon deploy. So I would literally, I do that source.env, I then take this and I just paste it in here, and then I hit run, and I'm not going to hit run because I don't have any of those things loaded up like I said I did, and then it would just do everything for me. And then if there's errors in your Solidity or something, or there's errors in your API key or in your RPC, you'll get errors and it won't deploy, but it will show you all that information. And that's what deploying looks like. And then you have your developed, tested, and deployed contract on whatever chain you just wanted to deploy to, and it's verified, and you're very happy.
And you're using state-of-the-art tools, and Foundry moves fast too. I see on Twitter like, oh, here's this new, if you want to grab information from a URL and plug it into your test to have your test dynamically grabbing from an API, we just added that feature. I mean, that was probably months ago, but you see those kind of things all the time on Twitter, so you know that the Foundry team is moving fast. Okay, almost done. I have this other question that's kind of tinkering around with Foundry maximalism, or maybe I'll call it Solidity maximalism. We see a lot of developers not wanting to F around with JavaScript. It's kind of like, ooh, yuck, no, I don't want that. I want a type safe language. I want to write my Solidity. But then when it comes to writing front ends, you almost always have to have JavaScript, even TypeScript, but it's not going to like your front end is just not going to be in Solidity for the foreseeable future. One day it would be great to have all these immutable front ends and this world that we're all kind of thinking of, but this move to testing and Solidity is a move, to me, away from JavaScript, which to me is a move away from developers kind of having a harmony between their smart contracts and their front end. And that's probably fine. It probably moves more toward, you have these like really hard, solid smart contracts, and there could be many, many front ends that interface with those smart contracts. And we're almost assuming that it's not going to be one full stack developer that bangs out the contracts and the front end in an evening. Like kind of you might do over in that remix scaffold ETH world.
Right.
The world is moving more toward, we need these hard contracts to be very, very well tested. Run your tests in Solidity where it's very native and makes sense to you. But there is just a tingle in the back of my mind that says, dang, I really enjoy writing my Solidity as I'm tinkering with it in the front end, and even like making buttons that start calling things like as I'm figuring things out. So there is, to me, like this a little bit of discovery that might be lost by diving deep into the Solidity testing maximalism, but maybe not.
Well,
what are your thoughts on that?
I would say my thoughts are, as someone who was never writing JavaScript tests in the first place, I was still doing all of that tinkering you were describing. So
by hand.
I just wasn't writing any. I was writing zero tests. I was only on Remix writing zero tests. I was still doing all of that tinkering because and I was just doing with the Remix and doing stuff on Rinkly, and then like seeing, is this showing up in my front end like I'm working? Is this button that I just coded working? Is it not? that was involving zero JavaScript.
Not even to a
tests.
local network too. I love that you're like iterating on a
Nah,
public
nah.
network.
Well, like, yeah, because it's like, I guess I could have obviously done it locally, but then I wasn't like, I never learned how to like fork I never learned how to like fork the current state of the chain correctly. So I was like, you know what, I'm just gonna use Ranky. It's fine. It finalizes so quickly. It's cool. So I would just like, to me, there's zero loss in any of my tinkering ability. I was never even writing tests in JavaScript in the first place. I'm now just finally writing tests, and I happen to start with Foundry because to me it seems like the thing people are using to, I mean, obviously that's like so vague. It's like, why did I pick Foundry? Because like
I don't
a lot
know.
of
I think
people
the
told
cool
me.
kids are using it. I think that's a good enough
like,
reason for a lot of things, because the cool kids are doing it. That's why.
Hey, because this dude Ian Nash, who is like the craziest Solidity dude ever, was like, I write my tests in Foundry. I was like, I'm gonna do the same thing, you know, like I'm not just gonna go out. So it's like, yeah. So I just say, I don't think writing your tests in Solidity are like changing the fact that you can tinker with your contracts, because the tests are actually separate, I think. And that's what is maybe a not a better point, but just a different point to make, is like your testing environment is like not necessarily related to your front end. Like when you're doing front end tests, you're doing stuff in your JavaScript React front end or whatever you're using. That's not necessarily related to like, or is all this logic that's in your smart contract correct? So I think it actually just brings out the point even more that like, these are different things. Like your smart contract lives over here. You can deploy a smart contract and no one can ever interact with it from a front end, and it can still have logic and just no one's ever using it, you know? Or it can just be a module that like other contracts are then talking to. So yeah, I think it just does highlight that difference between, or the separation of the smart contract and the front end more. And then I think what you said is really true, where someone can now become a Solidity developer and never learn JavaScript ever, and then never write front ends for their stuff ever, which I don't know if that's
which
like
is probably
a good way.
They probably will enjoy that.
Well, I don't know if that's a good way to learn stuff, because I think the way you've kind of sort of, and like Scaffold ETH as kind of like pioneered, is like getting the instant feedback in your front end right away. That's like really helpful to know if your logic is working, but you don't have to do dApp development that way. It can kind of be this more separated thing, and probably over time will become like that, just like as a lot of stuff over time becomes more specialized. So yeah.
So knowing that you've got kind of a tinkering environment and you've got this hard testing environment, and you just want to drop in and test something quick, you want to just try something out. What happens if I do this in Solidity? Maybe I'm thinking about writing a smart contract eventually. Maybe it'll become a project. Do you tinker in Remix and then dump it over to Foundry? Like, just kind of like thinking out loud, what is your tinkering look like now that you've found Foundry?
So I'd say one thing is I'm still not comfortable with Foundry, where like the barrier to entry of like, oh, I have to set up like a whole Foundry thing is still high for me. I don't think it will always be like that, but it is still for me. So I'm still going like that access control module. I wrote a version of it in Remix and deployed it in Remix and did a few checks to see like, after I deployed, does this thing work? And then it does. So I published like a few weeks ago, I published something I put on Remix out. And then once I was ready, okay, this is actually the way, like, you know, it's sort of like validating, like, is your thinking about the smart contract that you want to actually turn into something real?
You don't know if it's right or not.
Exactly. So I'm still going there. I was writing it just because it's literally just like your editor is right there. Like you just open Remix and it's just you're writing Solidity in like 10 seconds. So it's like, I just did that, deployed something. Then I confirmed it was kind of working how I wanted to. And I was like, okay, cool. I'm gonna now set up a whole Foundry like Solidity development suite and then actually get into it. So yeah, I'd say I'm still doing that. Maybe at one day when I get like very comfortable doing Foundry stuff, I'll move away from that. But for the time being, I'm still like doing initial baby little things in Remix and then grabbing the things that matter and putting them in larger suites.
Well, if the Build Guild does their job, hopefully there will be a Scaffold ETH that uses Foundry in the next 6 months. And when you want to spin something up, it'll be a quick command. But we'll see. We're working on it, but we're still learning, and we're way behind you. So this will be a helpful session for us also. So thank you, Max, for spending the time to go through and show your stack with us, show us off kind of getting Foundry set up and how to test. I just want to say thank you. Not just for today, but for everything you do for the Ethereum ecosystem and your work at Zora. And you know what this year has been for you is also been wonderful for the Ethereum ecosystem. And thank you for being here and keep building awesome stuff, dude.
Wow, to hear that from you, that's like the most amazing thing ever. So I'm very appreciative, and good luck with everything. And yeah, stay in touch.
Awesome. See you, Max. Thank you. Hearts.
Peace.